Assalamualaikum and hi everyone. My name is Nura binti Abdullah. I'm from AS1162F2. Today me and my teammates will be presenting to you group assessment from CHM256. Our title of the presentation are sampling.
So these are my teammates. Their name is Farah Fauzana binti Muhammad Fauzi, Nurul Nadira binti Ruzman, and Nurul Atika binti Mazlan.
What is sampling? Sampling is an act of collecting sample to produce meaningful information. In addition, sampling also is a process to get representative and homogeneous sample. The purpose of sampling is to obtain a representative sample of the whole sample that can be taken to laboratory for chemical analysis, and the result obtained will be accurate. There are two types of sampling. First, it is a homogeneous sample, and the second one is representative sample. Homogeneous sample is actually an analytical sample that has the same content. Meanwhile, representative sample is actually a content of analytical sample that reflects content of bulk sample. Now, we are going to know what is the factors of sampling. Actually, sampling have three factors that improving the results of sampling. First, it is size, and the second one is physical state, whether it is solid, liquid or gas, and the last one is chemistry of the material, which means the properties of the sample. We are going to know what is the accuracy and reliability that improving the results of sampling. Actually, this accuracy and reliability depends on how we take the proper sample collection for sampling, and the second one is how we transport our sample from collection to the lab, and then the last one is how we are going to take the proper selection of the lab sample.
Hi, I will present to you techniques or method of sampling. These are three things that we will cover up. So first, sampling liquids. Homogeneity of the material makes sampling of solid more difficult. The larger the particle size, the larger the cross sample should be. These are the methods: coning and quartering. First, you have to divide a pile of material into quarter, crush to form a smaller conical pile, flatten the conical pile, cut into equal, choose two opposite quarters, and then crush these two quarters, and you repeat this a step until you got a small sample. Sampling liquids. It's homogeneous and much easier to be sampled. If liquids are not homogeneous in small quantity, it will be shaken and sampled immediately. These are three types of liquids: large volume of liquids, large stationary liquids, and biological fluids. These are the examples. If water sample is taken from the river, then the water sample is collected at the surface, middle, and at the bottom of the river. If liquid is in a large container, the liquid should be stirred first before the samples are taken at the top, middle, and at the bottom of the container. Sample cases. There are two things you need to know. Crack sampling. Sample of air which is taken in flask, bottle, bag, or same container, and only take a few seconds or up to 1 until 2 minutes. Continuous or integrated sampling, which is case of paper had been removed from the amateur time periods and concentrated by passage through a solid or liquid absorbent, which is the cases is trapped in liquid or absorbed onto surface of solid. There are three methods. First, air analysis. Use high-flow sample content filter to collect particulates. Second, liquid displacement method. Sample must have solubility and not react with the liquid. Third, breath sample. Could flow onto evacuated bag, flask, bottle, and etc. Example, alcohol analyzer. Last but not least, dry sample. The method is dry in oven for from 105 Celsius until 110 Celsius. Only take 1 until 2 hours. If the sample is plain and tissue, it will only be heating. The problem, the sample itself can be decomposed at high temperature, loss of sample, or can be contamination.
There are three types of sample storage. The first one is liquid samples. We can store the samples in bottle with stoppers. The second one is acidic liquid samples. These samples can be stored in glass container. And the last one, the basic liquid samples. These samples need to keep in a plastic container. Next, the problem during storage process. The first one is foreign object may contaminate the samples. the foreign object example like paper or dust. The second one is analyte loss during storage. The third one is decomposition of samples. The fourth one is samples and glass container should not react. The fifth one is side reaction that happens, and the last one, if an analyte is volatile, it can sometimes get lost while samples are being stored, such as liquid samples. So now, let's move on to the sample storage and preservation. So, if there's a problem, there will be a way to prevent it. The first one is, once the sample has been collected, it must handle and maintain carefully to avoid contamination or other changes. The second one is, before doing the actual analysis, a number of safety precautions should be followed when handling and storing the samples. These can prevent the samples from the alternation or contamination that could be brought on by the container, the environment, or the light. The second one is loss of analyte as a result of atmospheric exposure or adsorption to a container's wall. And the last one is decomposition due to light, heat, and bacteria. So, from what I said earlier, we can apply that in preparing a laboratory samples. To make a liquid samples into a useful form, we need to convert samples to solid, since solids are usually ground to a suitable particulate size to get a homogeneous samples. To remove water from observation, we need to dry the sample. These are the issues that can arise when samples are dried. The first one is at high temperatures, samples could destroy. The second one is some samples can be dried in desiccators because they are heat sensitive. And the third one is side effect can occur. After the samples are dried, we need to do the weighing process. This process is to measure the quantity of the samples. We need to use the suitable apparatus for this process, and the balance room must be kept tidy.
And I'll be presenting my part about sample preparation and dissolution method. So what is sample dissolution? Sample dissolution is a process of creating an acid aqueous solution from an inorganic material. The most typical method is to directly apply one or more mineral acid. The term dissolution could also refer to the amount of solution that can dissolve in a volume of solvent at a particular temperature. So, we know it is divided into two methods, which dry etching and wet etching. Dry etching, which often done in a muffle furnace, is the technique of oxidizing sample by heating it at high temperature at 450 until 550 Celsius. It then results the sample in powder. So, when dry etching use heat, wet etching by oxidizing and dissolving the organic material in a sample using liquid phase reaction like acid and oxidizing agent. So the differences of drying etching and wet etching are: dry etching involves combustion of a sample in air, while wet etching involves liquid phase reactant, which is acid. Moreover, dry etching are simpler and fast, but it was less accurate at the result. The wet etching are using specialized equipment and more reagent, so the results are more accurate. Dry etching used for proximate analysis of ash content or specific mineral analysis, while wet etching as pre-analysis step for mineral that might be lost during dry etching due to volatilization. Next, for the eliminating interferences. What is interference? Interferences are chemicals that must be eliminated because they prevent the analysis direct measurement. There are five which are including 5 steps: precipitation, chromatography, distillation, dialysis, and extraction into an immiscible solvent. Standard solution. What is standard solution? Standard solution is a solution that contains an element or chemical in a precisely determined concentration. It is made using a reference material such as primary standard, which is a reagent that is highly stable, exceeding per free of fluids of hydration, and has a large molecular weight. It is to determine the concentration of other compounds such as solution in titration. Standard solutions are utilized, dissolve a known quantity of solution, then dilute the solution to a predetermined volume to create a standard solution. Typically, the concentration of a standard solution is given in units of molarity of mole per milliliter. So what is primary standards? Primary standard is a highly purified compound as a reagent while it is dissolved by accurate solid reagent in solvent to accurate non-volume as a solution. Secondary standard. Secondary standard is a solution that standardized with another standard solution, which means more than one reagent. Different with primary standard. Dilution. So what is dilution? Dilution is the process of reducing the concentration of a solute in a solution. It was when solvent was added to a solution, then result in a lower concentration of solution. For example, by adding water to concentrated orange juice to dilute it until it reach a concentration that is pleasant to drink. Like this area is a lot more concentration than the B result. So to get the B result concentration, which is less concentration, you need to add some ratio from the A to the B, so it will result less concentration of drink. So dilution can be done by using a simple dilution method or a serial dilution method. The simple dilution method involves mixing a known volume of solution with a known volume of solvent to get the desired concentration. The serial dilution method involves making a series of dilutions, each with a fixed dilution factor to get a range of concentration. Dilution is important for many purposes, such as preparing solution for experiments, adjusting the pH of solution, reducing the toxicity of substance, and enhancing the sensitivity of analytical method. We're using the dilution factor formula, which is the ratio of the solute to solvent, or simply the ratio of the volume of the initial solution to the volume of the final solution. Using the formula to calculate dilution factor is M1V1 concentrated equal to M1V2 diluted. For example, if you diluted 2 liter of juice with 3 liter water, then the dilution factor would be 3/2 or 1/5.
The conclusion is sampling is crucial in analytical chemistry because it allows analytical chemists to have a manageable size while analyzing a big population. In addition, sampling also main an important role in our daily life, and it also applicable in many applications in our daily life, and it make our life more easier.
That's all. Thank you.